Hello everyone, we are Group 8 from Class D, and today we'll be presenting on the topic of Internet of Things or IoT in pharmacy. My name is Syaira Anisatul Ilma, and I'm here with my teammates.
Azka, Izzati, Samara.
And I'm Zahra Shollikah.
In this presentation, we're going to talk about something that's increasingly important in the modern healthcare industry, especially in the pharmaceutical field. It's called the Internet of Things, or IoT for short. We'll explain how IoT is being applied in the field of pharmacy, the key components involved, real life case studies, and how this technology is shaping the future of healthcare and medication management, as well as its limitation and ethical considerations. So let's get started. This is an overview of what we'll be covering in our presentation. We'll start with a clear definition of what the Internet of Things actually is. Following that, we'll delve some real-world cases studies illustrating its application in pharmacy, such as smart pill dispensers, remote patient monitoring for chronic illness, and wearable biosensor for adherence. Following that, we'll discuss the various benefits, potential limitation, and ethical consideration associated with IoT in this field. And finally, we will conclude with a summary of our key findings and our recommendation for the future IoT in pharmacy. Okay, let's begin with the fundamental question. What is IoT or Internet of Things? IoT refers to a network of physical devices that are connected to the internet. These devices collect and exchange data in real time. For example, a smart thermostat that adjusts your home temperature remotely using your phone is part of the IoT. Well, that same idea is being applied in healthcare with smart sensors, automated processes, and real-time data analytics. Pharmacy operations are becoming faster, more reliable, and becoming more efficient. This opens up new opportunities for monitoring medication usage, managing inventory, and ensuring patient safety. And according to Statista, the IoT healthcare market is expected to exceed 534 billion US dollars by the year 2025, which tells us how massive and essential this technology is becoming. Next is about components of IoT in pharmacy. To understand how IoT works in pharmacy, we have to look at its core components. First, we have sensors, which detect physical changes like temperatures, movement, or pressure. These are essential in monitoring drug storage environment. Then there are actuators, devices that can make adjustment automatically based on sensor data. For example, if a room storing vaccine gets too warm, an actuator can activate cooling system. Third, we need network infrastructure. This includes Wi-Fi, Bluetooth, or even 5G signal, which allow devices to communicate with each other and with central databases. And finally, could cloud, cloud computing plays a crucial role. It stores and analyzes the massive amount of data collected by these devices, and often using artificial intelligence or AI to generate insights. Together, these components make IoT system function smoothly and intelligently. Next, we're going to talk about real-life example of IoT in pharmacy, and it will be delivered by our teammate Zahra.
Okay, let's continue with example of IoT use in the pharmaceutical world at the present time. The first is the smart pill dispenser. Smart pill dispenser are a great example of how IoT is improving medication management in the pharmaceutical and healthcare sector. These devices are designed to automatically dispense the right dose of medication at the right time. They are designed to connect to a mobile app or cloud-based system that notifies patient and caregiver when it is time to take their medication. The device is programmed with the time and details of the medication the patient needs. When the specified time is reached, an alert message appears on the patient or caregiver smartphone. How it works, the device stores multiple doses of medication. The device uses an internal timer and sensors to dispense medication according to a predetermined schedule. The IoT connectivity allows for remote monitoring by a healthcare provider or pharmacist. Observed outcomes. First, reduce risks of mixed or incorrect dose. Then, improved medication adherence, especially for older patients or those with chronic disease. Then, allows pharmacists to monitor patient medication adherence in real time and intervene when needed. Next, is remote patient monitoring for chronic disease. Remote patient monitoring, or RPM, is one of the most impactful IoT applications in modern healthcare and pharmacy practice, especially for patients with chronic disease such as diabetes, hypertension, or heart disease. How it works? A patient is equipped with an IoT-connected medical device such as a blood glucose monitor, blood pressure monitor, or ECG pads. The device collects vital health data continuously or periodically. The data is securely transmitted to a healthcare provider or pharmacist over the internet. The healthcare team can then analyze trends, detect early warning signs, and customize the right care plan for the patient remotely based on the patient's data trend. Observed outcomes. First, improve disease management and early intervention, reduce readmissions and emergency visits. Then, increase the role of pharmacists in providing remote counseling and medication adjustment. Then, a moving patient to take a more active role in managing their own health through real-time feedback. Then, the system also supports long-term data collection, which is useful for research and development of more personalized care plans. Next slide.
The next example of IoT in real life is wearable biosensors for adherence. One of the uses of biosensors can be observed in the concept of a smartwatch. These types of IoT are able to work subjectively, personalized based on its user's needs. These wearable biosensors have some similarities with the RPM that was mentioned before in terms of how it works. Wearable biosensors are predicted to have these possible beneficial outcomes. The first one is precision medicine. These are tailored treatments and customized therapeutic approach. And in wearable health tech, this can continuously track vital signs and provides real-time feedback, encouraging healthier habits and improving medication adherence. This type of IoT also has a medical impact because these biosensors are advancing the development of highly accurate health sensors as noted by D. Bhatia et al. In 2024. Next. Now I will be presenting about benefits, limitations, and ethical issues in IoT in pharmacy. Next. The development of IoT in the medical and health fields, especially the pharmaceutical field, certainly brings various benefits, both for the patient side and the health workers. Some of the benefits obtained from this development includes an informed decision-making, which ensures better clinical decisions using real-time and accurate data. It will also give transparent and fair AI algorithms, which ensures AI-driven systems to operate fairly and ethically. These systems can evolve and improve based on collected data and user feedback, which leads to continuous improvements. IoT also improved healthcare service effectiveness, which makes healthcare delivery faster, more efficient, and more personalized. Though it is beneficial, there are also some limitations that could be considered while applying this IoT in real-life situations. There are limited durability and longevity. The cost and scalability of this IoT is also an initially high investment, which may be difficult to implement on a large scale. There are also ethical considerations and privacy concerns, and the final limitation is the facility coverage. Scale is also a hard key to cover because not all healthcare facilities may be equipped to support IoT technologies. And as mentioned above, there are also some ethical issues that could possibly arise in the integration of IoT in pharmacy, such as patients' data insecurity that has the risk of data breaches or leaks, informed consent and patient autonomy, which means patients must fully understand and agree to how their data will be used, and potential bias that the AI systems or data interpretation might do unintentionally and favor certain groups over others. Next. And as for the summary, this presentation included that Internet of Things or IoT is a technology which refers to a network of physical objects, devices, vehicles, and appliances embedded with sensors and connected to the internet to exchange data and ease as humans work. Some examples of IoT in pharmacy and healthcare are smart pill dispensers, remote patient monitoring or RPM, wearable biosensors such as smartwatches. There are also benefits of IoT. There are data-driven decision making, continuous improvements in healthcare delivery, transparent AI systems. There are also limitations or challenges and ethical issues. The technical ones are devices durability, cost of facility, and scalability. And the ethical ones are data privacy and security, informed consent and patient autonomy, potential bias in the AI system in charge. And these are the references that our group are using to make these presentations. Next. So that concludes our presentation. I'd also like to suggest some recommendations for the future of IoT. One of them are to enhance data security and clear privacy protocols. These suggestions could possibly come true by doing some real-life workshops and socialization about these IoT technologies towards related health workers and patients. Thank you for tuning in our presentations. Have a great day ahead. Assalamualaikum warahmatullahi wabarakatuh.